Hello, my name is Bradley Van Dam, and I'll be showcasing in my Physics 4 demo the principle of total internal reflection using a glass full of water that is clear and a laser pointer. And I'm in the bathroom because I'm gonna turn the light off and you'll be able to better observe how the laser interacts with a different medium that's not the air, because the light will behave differently depending on the medium that it's traveling through. So for example, if I point the laser, it'll behave kind of how you always would expect a laser to be, just kind of very straightforward. But if you do it through a different medium like water, it will behave slightly different. So let me turn the lights off. So we have our incident ray, or the laser. Get low here. So if I go and point the laser into the glass, you can see, and depending on which angle I have it, behaves slightly differently. But as you can see, it is not actually leaving the glass. Instead, it is bouncing off the edge of the glass. Eventually, it does leave the glass at some point, but at first, it is bouncing off of the side of the wall. And this is due to the critical angle that occurs when you have an incident ray coming in through a medium. So we have initially the first outside fluid is air, and the second medium is water inside the glass, which is denser. So it is going to stay inside of the water for as long as possible since it is denser. And we have, and depending on, obviously I can't exactly showcase this in this little experiment, but depending on the angle at which the incident ray is coming in, let me turn the lights on. Ooh, I gotta find the lights. So say if we had a very narrow glass tube filled with water, we would be able to see it bouncing back and forth, almost similar to fiber optic and how that behaves. And also if you go to, depending on how you calculate the critical angle, I believe it's n equals something over sine, I believe, to calculate the critical angle. And so you do the inverse sine to calculate the critical angle for the specific medium that you're traveling through. But so say, for example, if I were to exceed or go past that angle calculated, then it would not behave as we just kind of illustrated before. It would not bounce. It would just go and straight be refracted from that medium. So actually, let me turn the lights off one more time. And if I just do this, another just a little illustration. So this one's a little bit harder to see, but it's just proving the fact that it wants to stay inside the glass because the water is a denser medium than air, and that the light is behaving differently based off of the fluid that it's traveling through. So it's a little bit not as strong if I were to put it to the side of the glass instead of straight down, but you can still see it is somewhat staying within the glass. So that is the principle, or that's, I guess, a showcase of the principle of total internal reflection.